This tutorial is for educational use only. It is not authorized nor approved for any other use.
We are going to be deploying the reserve smart contract. We are going to write the entire smart contract in this video. Because we remember on the last video, we talked about having a smart contract that is going to hold the USDT and WETH collateral. Okay, so with that collateral, we are going to be backing up our algorithmic stablecoin, and we're going to be providing the $1-to-1 value to each token. So for that, I need to do the following first. Right now, what I'm going to be doing is I am going to be building two smart contracts, but they're literally mock-up tokens, or they're fake tokens to simulate the USDT and the WETH. Because again, I don't have $1 million. I don't have $1 million, not yet. Once I get that information in the blockchain, I get those smart contracts, I'm going to mint the supply, and we will transfer the supply to the reserve. Okay, so we are going to be building the reserve smart contract, and it's going to have what? It's going to have the two vaults. We're going to be building vault number 1, or in this case, if we are working with structs and we're doing mapping, the first vault, it's going to be vault 0. Vault 0, it's going to hold the USDT. And vault 1 is going to hold the WETH, or the wrap ETH. The token, the Ethereum token, is not native to Polygon. The Matic token is native to Polygon. So in order for me to obtain Ethereum in Polygon, we are obtaining a wrap token, which is basically a token that is associated to the actual Ethereum token, but has been bridged into Polygon, okay? So that is in a nutshell. So let's go ahead and build two ERC20 token smart contracts. I'm going to be doing this very fast so that we can focus our attention in the reserve smart contract, which is what we are here for. Okay, I'm gonna go ahead and initialize the contract. So we are going to be initializing the contract, and I have to import some libraries that I need to use. Basically, I need to be importing the ERC20, the safe ERC. This is a very normal ERC20 token smart contract. Okay, so I have a couple of videos that I go over in ERC20 token smart contract. It's very straightforward. Okay, so with that said, let's do the following. Okay, so I'm gonna go and bring the contracts that I need to be interacting with. So then I can use the functions here. Ownable, ERC20, safe ERC20, because we're gonna be using the safe transfer from utility. And we are going to be also allowing the burn. But again, this is just the ERC20 token smart contract. This is not the reserve smart contract. I'm gonna go very quick on it. Okay, so what I'm going to be doing now, I'm going to import a contract that I already have pre-made. It's very straightforward. So what we're doing, it's basically creating the contract USDT, and we are just importing those libraries in and those interfaces, because I have to use those interfaces to interact. This is a token smart contract where, you know, in the real world, or in this case in production, you're not doing this because you're buying the USDT, right? This is just a mock-up token, okay? Tether USD, USDT, and then I have the mint function here. I'm just gonna call that, okay? Cool. So we got that. Let me go ahead and copy it, and we're gonna deploy it real quick. So let's Control C, and let's go back. There we go, awesome. So what I'm gonna do now, I'm going to Control S, and I'm gonna go here, and I am going to connect my wallet. This one, okay? So I'm gonna use this wallet, perfect. Now let me switch myself, and yeah, let's deploy the smart contract. And now we are asking for approval. I'm just gonna use the market here and press OK here and wait for the approval. Then we'll do the same thing with WETH. So now I just have the smart contract ready to go. I am going to be minting the supply. So we mentioned in the first video that I'm going to be allocating 200,000 USDT as collateral A. So let's do that. Okay, so what I'm going to do, I have to type the 200,000 value in way, which means that I have to type 200. That's 200,000, right? And now I have to add 18 zeros, okay? And there you go. So we added the 18 zeros. So now we have the value in way, okay? Now let's go ahead and mint. I should be getting the prompt. Okay, beautiful. I have the market, bam. But in the real world, you're not doing this. In the real world, you need to have $200,000 worth of USDT. Beautiful. Okay, so we got the mint. How do we know that we have the 200,000 USDT? We are just going to add the contract address into my wallet. Let's go ahead and do that. I'm going to import the token. I'm going to say this guy, and this should reflect USDT, custom, and sure enough, we are rich. I wish. Okay, awesome. So we got the USDT. Now what we're going to do, we are going to leave this here because I am going to be interacting a little bit on this smart contract, not in the sense that I need to have access into the real USDT smart contract. But remember, we are going to transfer or deposit that onto the reserve smart contract. But first I have to approve the spending of those tokens. Don't worry, we're going to go through that. It's very simple. Okay, so now what I'm going to do, I am going to be naming this WETH. I'm going to say wrapped ETH. Okay, and then we'll say the symbol as WETH. Beautiful. And we're going to Control S, and now we're going to deploy the smart contract as well. And this is our unstable collateral. Okay, confirm, and now we should have the smart contract. We got the smart contract, so let me scroll down here. And now we are going to mint 100,000. Remember the first video? We already have 200,000 USDT, and now we are going to mint 100,000. Actually, no, I am not going to mint anything. And the reason why I'm not going to mint anything is because we don't know the price of that token. So I don't know how much I'm going to mint. All right. So we are going to deploy the smart contract. We have the smart contract ready to go. We are just going to add the smart contract into the reserve smart contract. We're going to create the vault and we'll add the WETH smart contract to the vault. But we are not going to mint anything, at least for sake of the test, because we don't know what the price of ETH is. Okay, so we cannot mint because we don't know how much supply do we need. Okay, so we'll come back at that. Don't worry. We are building the reserve smart contract. Let's go. Okay, so the first thing I have to import is going to be the ERC20 interface because we are going to allow this smart contract to hold the collateral, the ERC20 collateral, which means that I have to have an interface so then it can talk to an ERC20 token smart contract. You see where I'm going? I have to be able to draw, deposit. I have to be able to do the safe transfer from. That's why I'm invoking this, okay? And we're going to be using, again, the safe transfer from function. We're going to take advantage of that utility, right? Next, I am going to be doing some math formulas. Very simple, very straightforward. You are going to see, but I need to use the new format to do calculations, which is the safe math utility. We're going to be using Ownable, because I should be able to call functions only by the contract deployer. It's re-entrancy guard. Let's protect the double entry and let's make sure that the function is protected from that perspective. And access control, because only certain people or certain contracts can call this reserve smart contract. Okay, we are going to be limiting who or what can talk to those functions. Okay, and you're going to see this is how we do it. Beautiful. So now what I'm going to do, I'm going to call this N2 USD reserves. Okay, so this will be the name of the smart contract. By the way, I'm going to just name this N2 USD reserves. Okay, I don't need any of that. Well, ownable, yes, ownable. It's going to be something that I'm going to be declaring this. It's going to have re-entrancy guard, right? And it's also going to have access control, which are the three utilities and the security mechanisms that we're going to be applying here. Okay, beautiful. So now what I have to do here, by the way, you know what? So you are not confused. Let's go over it. Very simple. Okay, so what I need to do now, I have to invoke the safe ERC for ERC20. So that allows me to make sure that, hey, I am going to be using safe ERC20. And also I am going to be using safe math for UINT 256. Anytime that I need to make some calculations, I am going to be using that safe math utility. Okay. We are going to be using safe math for UINT 256 and safe ERC20 for IERC20. So we are going to be using the safe transfer from on this particular scenario. Okay, here goes the fun part. So the first thing I have to be building, it's going to be the vault ID allocation. So basically what I need to do is the following. I am going to be drawing this because I think it's make more sense if I draw this for you guys, okay? So check this out. So we got a visual representation of the reserve smart contract, right? In that scenario, I have to be able to identify how the contract is going to be constructed, okay? So the first thing that I have to do, I have to be able to count how many vaults I am going to be creating. But that requires a counter. Why it requires a counter? Because I need to be able to call a particular vault using my functions, okay? So the first thing I got to do is the following. I am going to be creating a mapping, okay? This is how we are going to reference the storage, and we are going to be able to write and read onto this particular smart contract, which means that I have to do the following. I am going to be calling this RSV vault. Okay, beautiful. So this will be the public name of the mapping. It's going to make sense once you see it. Okay, don't worry. So this is the public name of the mapping. Okay, underscore RSV vault. Inside this public mapping, we're going to have the actual vaults. Okay, the first vault, we're going to call the vaults reserve vaults. Okay, so let me change the background color to be green. Yeah, that works. This will be called reserve vault. Okay, reserve vault. So gonna be all together. There we go. This is going to be the first vault in the smart contract. This vault is going to store USDT. Okay. What two items do I need to have on the vault? I need to have number one, the smart contract address, or this is the USDT smart contract address stored in the vault so that we can reference what this vault is for. Okay. And also we need to have the amount of ERC20 tokens that we have stored as USDT in this reserve vault. So how do we interact with a token smart contract on a contract that is not for a token? Okay, so in this case, I want to store tokens into the smart contract. It's not going to be a token smart contract, right? So how do we do that? We are going to be storing the IRC20 and then the collateral address, okay? We are going to be referencing IRC20 to the collateral address. So then we can make calls into the USDT contract. So let's go ahead and do that. So the first thing I'm going to create inside the struct is going to be IRC20, and then we're going to call this collateral. Beautiful. Now the second thing that I need to store, as I mentioned, is going to be let me just zoom in. I think it's going to be better for you. The amount of tokens that we are storing. So every time that I make the call, I'm going to be storing that amount. So I am going to call this UINT256. I want to say amount, okay? Beautiful. So check this out. Now that I have the first vault, every time that I make a vault, I need to assign an ID or a number so then I can call a particular vault. If I need to interact, if let's say I need to deposit USDT, I need to know what the vault ID is for USDT. If the first smart contract, or in this case, the first smart contract that I'm going to be adding onto this reserve smart contract vault is the USDT, well, guess what? Vault 0 is the USDT vault. When I add the ETH smart contract, vault number 1, it's going to be ETH. Okay, so if I need to deposit, I am going to be referencing the ID of the vault, and then I can make the call. I can do the say transfer, I can do everything. That's how we are doing it right here. Okay, it's not difficult. You're gonna see it once I start writing and coding on the actual smart contract. You're gonna say, oh, that makes sense. Okay, so we said that this is going to be vault 0 because we're gonna be adding first the USDT. Okay, then the next vault that I create, or I add the ERC20 token smart contract address, is going to be vault 1. So every time that we keep adding new smart contracts, like let's say we're going to store Algorithmic, it's going to be vault number 2, vault number 3, vault number 4. So every time that we add a new token, we're going to be creating a new reserve vault, and this will be mapped to RSV vault. Okay. How am I going to reference RSV vault to the actual vault? This is the public mapping name that will allow me to write to individual vaults. How do we do that? We are going to be declaring mapping. Okay. And we are going to say what? UINT256, remember, is an integer mapped to what? It's going to be mapped to reserve vault. Okay. I'm calling reserve vault. Vault. We're going to close this here. Now we have to declare this public. Why? We want to be able to make calls from the outside into the smart contract. Okay. So this will be public. And what's the name of that public mapping? RSV vault. Okay. Awesome. We're going to call this RSV vault. And it's going to be underscore RSV vault. That is beautiful. Okay. That is literally how you map it. So every time that I make a new call, I am basically telling 0 reserve vault. So every time that I call this RSV vault and I tell RSV vault and I say ID 0, it means that I'm going to be interacting with this vault. And if I say RSV vault 1, it's going to be this guy right here, the second vault. Okay. In order for me to provide a number so that we can keep track of how many vaults do we have on the smart contract, I need to be able, and by the way, this is being cut out. Let me just do this. There we go. Beautiful. So every time that I make a new vault, I have to make sure that this counter keeps increasing. So we know how many vaults do we have. And if we need to make a call that is going to talk to all the vaults, I need to have a counter. So then we can use that counter in a loop and then call every single vault. And you're going to see it. Okay. So for that, I need to be declaring that integer. Okay. I'm going to create that public variable integer. It's going to be 256. And we're going to call this current vault ID. Okay. Or we can say current reserve ID. Okay. And we are going to be declaring this to be a public. Okay. Because remember, I want to be able to obtain the value outside of the smart contract. And I have a typo here. No worries. Cool. Awesome. Now let's build the vault. Let's build this structure right here. Okay. So for that, all I have to do, I have to type struct, and we're going to be calling reserve vault, right? And then we're going to open that vault. And the first thing I'm going to be invoking, IERC20, and we're going to call this collateral. Beautiful. Awesome. Then the next thing that I have to do, UINT256, amount. Beautiful. We already built this structure right here. Okay. Now we have to build the mapping so that we can be referencing individual vaults. Okay. I'm going to call this mapping, and we're going to call this UINT256, and we're going to call inside to reserve vaults. And then we're going to declare this to be public, and we're going to say RSV vault. Beautiful. Awesome. We have effectively done all this. Now, every time that I create a new vault, it's just going to have a new ID. This starts with 0. So the first ID that we are going to be assigning is 0. Okay. After I create that vault, and you're going to see it now, this will increment to 1 and 2 and 3 and 4, and it's just going to continue. Okay. Now we want to create 2 events. Every time that we deposit and every time that we withdraw. I want to be able to create an event. We're going to be able to obtain and do auditing in the future. Let's say we want to obtain information about a particular transfer event or deposit or withdraw. We want to have the event. Okay, we want to have that. And we're going to call this event withdraw. And we are going to say UINT256. We want to make sure that we have it indexed, the ID, which is vault ID. Okay. And finally, we're going to do UINT256 amount. Okay. Beautiful. We got the first event. And now I have to do the same thing with deposits. I'm just going to copy it. I'm going to go ahead and paste. I'm going to say deposit. Okay. And we are just going to have basically the same parameters. Okay. Beautiful. Now I have to create the access control role. Basically declare a access control byte32 value that will be assigned to wallets or contracts that are allowed to make calls into the reserve smart contract. Okay. Awesome. Let's go. Okay, and this is basically the access control role. I am not going to go too much in detail with it. I have a great video that I go over access control in detail. Leave the link to that video here, okay? Beautiful. So we got that access control, and now we are going to call the constructor so then we can assign the deployer of this smart contract already the manager role and the admin role. The admin role basically allows the owner of the smart contract to add more people or more wallets or more contracts as managers. Okay, so let's go ahead and paste that in. So this is constructor and not necessarily need public. Now this after compiler version, I think 7.11. Cannot remember the exact version, but you don't need to declare this to be public. You don't need to. Okay, and this is basically what I'm doing. Whoever it's the message.sender, set it up how you initialize the contract basically. Okay, so we are good so far. We got the N2 USD reserves. And now after I enable all this, first of all, I want to make sure that when I add a token, I add the token smart contract only one time, the address protection mechanism to avoid from a developer, a developer committing a mistake that he decided to create a new vault with a token that was already added. Okay, we already created, for example, USDT, vault 0. When we create vault 0, if someone decides to do a new vault and paste the USDT smart contract, it's going to error out. We want to avoid from creating a new vault with the same token type. Okay, that allows me to make this very consistent and avoid that type of confusion, discrepancy, right? We don't want to have that. We want to have vaults for each unique token, not duplicated tokens. Okay, so what we're going to do, we're going to call this function check reserve contract. Okay, and this will be an internal function because I am going to be using this function in the add vault or add reserve. So the first thing I'm going to be checking is making sure that the token contract that we are adding as a vault is not already being added. And what we're going to do, we're going to call this internally. We don't need to be calling this externally because I don't care, what the contract is on the interface or on the reserve, right? This is more as an internal function, right? And then with that, what I have to do, I have to make sure that I can place or I can bring the value in the interface as a parameter. I have to make sure that I can pass that in. So I'm going to say IERC20, and we are going to say collateral here. Let's just declare this collateral. So now I'm going to show you here so it's more clear. Okay, if I need to draw something, I'll just bring the other monitor or the other window right here. Okay, so function reserve contract. Beautiful. So the first thing that I have to make sure is the following. Now here comes the fun part. I got to make sure that I checked against all the contracts that already have been added, which means that I have to be doing a for loop that is going to check against all my reserves. If I make 2 reserves, we're going to have ID 0 and 1 active. Okay, so I have to make a for loop for that. So check this out. I am going to say for, let's build that for loop real quick. It's going to be UINT256. We don't have to do this, by the way, ladies and gentlemen, we don't have to because we, by default in Solidity, we have I as 0. So I don't need to declare that. Okay, just FYI. By default, this is 0. So I don't need to declare this like JavaScript or any programming language that I have to declare that value. Here, I don't. Okay, so what I'm going to do, I'm going to say if I is less than current reserve ID. Remember the vault IDs. Every time that we make a vault ID, this number will increment. If we have 2 vaults, this ID must be 2. Okay, it's going to be 0 and 1 active, and 2 will be the next available ID. And what I'm going to do, I am going to increment here. I'm just going to do I here, right? And now we are just going to take advantage of that. Okay, so with that said, I have I. Now I have to take a look at that. I'm going to do a require, right? So what I'm going to be requiring, if that the current IERC20 contract collateral address in the vault doesn't match the one that we are trying to create, which means that what? I have to create that require statement here, that condition, okay? And this is a very simple to declare. How we are going to access the value? We are going to access the value by calling the mapping. So this will be RSV vault. I'm just going to Control C, and we're going to say RSV vault. Then we are going to be calling the particular vault. But remember, we have to check against all the vaults. Remember, every time that the for loop runs, I is just going to be incremented. It's going to check 0 and it's going to check 1 and done. That's it. Okay. So with that said, I'm going to say what? I am going to say collateral. Okay. That is the name of my variable, in this case, the IERC20 address. Okay. I want to check against that address. And we are going to make sure that is not equal to whatever value is the user calling in the add. Remember, this is internal, but we are going to be invoking this here, okay? If it is, for some reason, collateral address already added, okay? And that's it. I'm going to say here and boom. That should be it, okay? So with this, I'm going to make sure that if we're adding a new vault, we are not going to duplicate that, okay? Now let's go ahead and add the vault, okay? Let's do the vault function. Let's call this function add reserve vault, okay? What am I going to ask? We are going to be asking the same thing. We want to ask for that IRC collateral address, in this case, the token USDT smart contract address, or the other token that we want to, any token, right? And we're going to say external. We want to, start writing here. Okay. So the first thing that I have to do, I have to make sure that whoever calls this, it's allowed by the role. Okay. So we're going to be adding that right here. We're going to add that function that will check whoever calls this function. And here we go. So I'm going to go ahead and paste that in. And basically, I'm going to check if the message that sender, whoever is calling, has this role applied to, or else I'm not going to allow you to. Okay. So now what I need to do, I have to, first of all, I am going to check that reserve is not already created. So I'm going to invoke that function, right? And what are we passing? There you go. That's how we check first. What I'm going to do, I am going to be calling this once I hit this add reserve vault, and this basically internally is going to check and make sure that address is not already added as a vault. Okay, beautiful. Now, if it goes through successfully, didn't stop here, then I am going to add the vault. Okay, and it's very simple. By the way, you have it right here. I love to use copy and paste. So what I want to do here, I'm going to paste this in, but instead of we are going to declare that current reserve ID. Remember, that is the value. Every time that we create a new vault, we are going to be increasing this counter right here. We build that counter that starts with 0. So guess what? The first time that I run this function, it's going to create vault 0 because this is again 0. Okay. And what am I going to do? I am going to be doing equals to what? Collateral, which is the value that I will be providing externally. Okay. This is external. I'm going to be providing collateral, and collateral goes here. Beautiful. Awesome. Now I have to make sure something. I have to make sure that I increase this current reserve ID, or else what's going to happen? The next time that this is called, it gets replaced. 0 becomes the new token. We don't want this. We want to keep creating new vaults. Remember, vault 0, vault 1, go back, vault 0, vault 1. But that current reserve ID, it's this value right here. So every time that I run this function, I have to make sure that I increase this value. So then it keeps increasing, okay? Every time that you call this will be increased. So I have to say the following. I'm going to say current reserve ID plus plus. That's it. That will keep increasing every time that this passes, increases the counter, and it continues assigning new values to new reserves. And we also avoid the reserves from being duplicated with the same smart contract, okay? And that's it. That's it. We are done with the reserve vault, okay? Now, we are going to do the following. We are going to create the functions to withdraw and deposit. Okay, so we are going to create the function first to deposit collateral, and we are going to create the function to withdraw collateral. That's it. Deposit collateral. Okay, and we are going to say external, and we're also going to make sure that this function only can be called by the manager role. All right, and I am going to make sure that I provide the parameters. What am I going to provide here as a parameter? Because I am going to be depositing collateral, I don't know to which vault am I going to be depositing the collateral. Am I going to be depositing USDT or WETH? That means that if I'm going to be depositing USDT, I have to provide vault ID 0. Okay, so we're going to say UINT256 VID. That's the vault ID. Okay, and then I am going to provide UINT amount. Right? Because that is the amount that I need to provide, the amount that I'm willing to deposit. Beautiful. Okay, awesome. So we're good here. Now I need to be able to call the safe transfer from. Safe transfer from is the function in the IERC20 interface that allows me to transfer the tokens into the smart contract. This will be called to the actual token smart contract. So first of all, I have to declare a IERC20 interface that is called reserves. You're going to see why. There's many ways. People, if you already know the struct model and how can we reference structs to interfaces or whatnot, you know that this is not the only way, but I am going to be doing it this way because it's going to be cleaner for me in this case for this particular smart contract, right? So what I'm going to do, I'm going to copy this, and basically what I'm doing, I'm declaring this to be reserves. Okay, now I can type reserves dot then the function. Okay, but remember, we are not going to use current reserve ID. We're going to use VID because I will be providing what vault am I going to be depositing the tokens to? And this will be referencing that particular vault, okay? Simple. Now we have the interface. Now we need to declare the action, okay? Here's the thing, reserves.save transfer from, that is the interface in the smart contract. And first, it's going to be from. It's going to be address from who? From me. Message sender. Okay. Now it's going to be to what? Address. Address what? This. This means this smart contract address. So I am going to be transferring from my wallet to the smart contract address. And finally, the amount, which is what am I going to be passing from the outside? Simple. Okay. Beautiful. So we have effectively done the transfer here. Okay, now we are going to declare the following. I have to update the vault with the amount that was deposited, which means that I have to, number one, get the amount, the current amount that is already deposited, and add anything extra. Let's say we already have 1 million USDTs on vault 1, right? And I want to deposit 100,000. I need to be able to first obtain what is already available and then add the 100,000. So then it updates the value, okay? Very simple. So first of all, I'm going to say current vault balance. This is the balance of the vault. I'm going to call the vault itself. And again, I love to copy and paste. In this case, we're dealing with a particular vault ID. So I have to make sure that I'm passing that particular vault ID, right? And instead of collateral, I'm just going to call the amount. That is my second declaration in that struct. Now I'm going to be passing this current vault balance, okay? Now, check this out. What am I going to do? I am going to be updating that value. Okay, I'm going to grab the amount. We're going to be invoking that struct. And we're going to say, now the new amount, it's going to be whatever you have before, current vault balance, whatever was already stored there, dot add, safe math. One of the functions is to add. And we're going to pass what? The new amount. Okay, so this is the amount that I'm passing here. What's going to do? If there was already 1 million tokens in the vault, I am going to be storing that here. Now, grab the 1 million tokens and I want to add the new amount, 100,000. So now we are going to be ending up in this particular vault value or vault amount, 1,100,000. That's how we do it, okay? And at the end, I want to make sure that I emit the event. So because we want to have records of that, we're going to say deposit, right? And we are going to be passing a VID, and we are going to UINT 256 VID. And we are going to be passing UINT 256 amount. So we have records of that. And there you go. We have made the function to deposit the collateral. Beautiful. Now we need to do the same function, but this time it's going to be to withdraw. Let's do it. Let's copy and let's go ahead and move here. I'm going to just move it right here. I'm going to show you here. In this case, we're going to withdraw collateral. Beautiful. We're going to withdraw the collateral, and basically we're passing the same arguments. We're passing VID and we're passing amount. Okay, we're going to make sure that the role is the manager. Beautiful. We're going to be looking for that reserve vault ID, or the reserve smart contract. I have the reserve declared. Now I have to obtain the value or the amount that we have already available on the vault, which means that I have to do what? I am going to grab this. The current vault balance is going to give me that amount. I'm going to cut. I'm going to throw it here. I am going to do the following. I am going to say if, and we're going to say current vault balance is more or equal to what the amount is. That means that I have the collateral. I have the balance available, so then I can withdraw. I'm going to make sure that current balance, it's higher than what you're asking me. It's either higher or is the same as what you're asking me. So then I know that I have the collateral here, or I have the balance available, so then I can withdraw it. It's a security mechanism, right? And inside here, we are going to, provide the action, right? And now we're going to say the same thing. Instead of us doing safe transfer from, now we are doing the opposite. I'm going to be safe transfer because it's from this address to message.sender. We already know that it's to message.sender and the amount. It's not going to be this one, right? It's just going to be that. There you go. And now we got to make sure that if current balance is more or equal to the amount that you are requesting, then allow you to withdraw it. But guess what? I also have to update the vault. Remember, the vault has saved at 1,100,000 as the value or as the amount. So I have to lower that with the amount that I withdraw. So then it matches, right? It's consistent. Okay, so now what I'm going to do is what? I am going to say that the new amount of the vault is the current balance minus, so in this case, it's going to be sub amount, the amount that you withdraw. If you withdraw the entire amount, that means that this will be 0. So this value will return back to 0. Okay, beautiful. And now we are just going to change the emit to be withdraw. That looks awesome. Okay, so what I'm going to do here, I'm going to fix a little bit of the indentation. There we go. What else do we have? We are done here. Cool. So we have the check reserve contract. We are going to make sure that there's not already a contract with that address as a vault. We're going to allow to create new vaults. We are going to deposit collateral onto the vault, and we are invoking that vault ID. Yeah, that looks great. I don't see any more problems. And that's it. We are done with the smart contract. Now it's time to deploy this smart contract. Let's go ahead and do it. Something that I did that I realized I did wrong. There's actually 2 things that we have to fix on the smart contract, but they're very quick. I'm like, that should not be there. Let me show you real quick. It's on the withdraw collateral function when we are specifying if the collateral balance is higher than the amount that I'm asking to withdraw. We also have to update the struct or update the reserve vault with the balance inside the if clause, because else it's going to update regardless if it's matching or not matching the condition. And we don't want that. We want to make sure that we only update if we have the collateral available to execute the withdrawal. Okay, let me show you. It's very simple. So you can see right here that we have the if clause that shows current vault balance. That is the vault balance on the vault itself. So if we are calling VID 0, that is the USDT vault. In case I decide to put the first reserve contract and build the first vault, it's going to be USDT and it's going to be VID 0. Okay. So the problem with that is if I inject this below the if, like after the if, it's going to update regardless if we have the balance available to execute the withdrawal. We don't want that. So what I'm going to do, I'm just going to cut it. I'm going to throw it inside after the safe transfer. That way it only executes and it only updates the vault if we have the amount available. Else we're not going to be able to update the vault. Okay, awesome. And the other thing that I'm like, okay, you know, when you are developing and you're writing, you go in auto mode. Especially when I'm recording videos, I go auto mode. Like I'm just going with the flow, right? So when we talk about emit an event, you don't have to declare the variable inside the emit event because it's already declared. We are only going to place the name of the object, or in this case, the name of the value that we are going to be passing onto the event. Okay, when we are going to emit that event, we're just passing the value. I don't need to redeclare that. I'm like, no, this doesn't look right. Okay, so in this case, I am removing the UINT256 because again, this is just me passing the value. We already wrote that event here. So when we go here, we already declare that right here. So, oops. So that means that I don't need to redeclare that. Okay, good so far. Awesome. And that's it. Now we are definitely golden. Let's go. What I'm going to go now, I'm going to copy this smart contract and we're going to deploy this. I'll add the first reserve vault, which is the USDT, and we'll deposit the collateral and we'll add the second vault contract, which in this case is WETH. And we are done. Okay, so let's go ahead and test it out. So I'm going to do here, I'm going to select all, I'm going to Control C, and let me go to my browser and execute. Okay, so what I want to do now, I'm going to create a new file and we'll call this N2 USD reserves. Okay, so let me go ahead and do it real quick. I'm going to create a new file, N2 USD reserves, sol. Okay, so I just pasted the smart contract and let's review everything one more time. Okay, so everything looks good as far as the imports. Let me go ahead and Control S to see if it compiles successfully, and sure it did. Beautiful. Okay, So now what I got to do, I have to deploy this. And if you remember, we already have the 2 token smart contracts that we are going to be working with. We got the USDT and we got the WETH. So let me go ahead and deploy this. Okay, let me make sure that I'm using the right wallet. Yes, I am. And let me go and deploy. Beautiful. We got the prompt. So let's deploy it right now and wait for that confirmation. Okay, we are done. We are done. Beautiful. We got the confirmation. So let me check my contracts. Sure enough, we got the N2 USD reserves smart contract. Okay, the first thing that I'm going to be doing is I am going to be adding the USDT smart contract. Remember, we talked in the beginning of the video when we were writing this smart contract, the first vault that we add, in this case, the first smart contract that we add when we execute the add reserve vault is going to be vault 0. It's going to be assigned a vault 0. How do we know that? When we hit current reserve ID, you are going to see 0. That means that this is going to be the first ID that we will assign to the vault. So if we add the USDT smart contract onto the reserve as our first reserve, it's going to be vault ID 0. Okay, beautiful. So what I'm going to do, I'm going to copy the smart contract, the USDT smart contract. In production, if you're holding USDT tokens in the Polygon blockchain or in the blockchain that you are, you're holding those tokens, then you have to find the smart contract address for USDT. Okay, so you need to find the real smart contract address and we'll add this in the reserve smart contract. Okay, cool. What am I asking here? It's the collateral, the smart contract of the collateral itself. So in this case, USDT, we're gonna copy the address and let me go ahead and paste that in. Beautiful, cool. So we're gonna go ahead and transact and we are getting that confirmation right here. We're gonna confirm and we have our first vault created. Okay, let's wait for the confirmation. We got confirmed. Beautiful. Awesome. All right, so let me scroll here so you can see it's been confirmed. Now, let's take a look at the vault. Okay, so if we go under the RSV vault and we type 0, remember, vault ID 0, we have the collateral smart contract, which is the USDT smart contract, and we can see that we have an amount of 0, meaning that we don't have anything stored yet. Let's change that. Let's store the 200,000 USDT into the reserve. What we need to do first, remember, this is a smart contract. If we take a look at our smart contract, I'm going to show you the deposit collateral. What it's going to do is going to invoke the interface, right? So we are going to be invoking the USDT smart contract and we are going to call the safe transfer from. In order for, listen carefully, I'm gonna say it again. Listen carefully. In order for a smart contract to move funds on behalf of the wallet, on behalf of the user, in this case me, it needs to be pre-approved, which means that I have to send a call to the USDT smart contract and I have to say, hey, this address, please pre-approve to move X amount. Let's do it. I'm going to show you. It's very important, okay? Because a smart contract is going to be moving funds on our behalf. So we have to make sure that we pre-approve that or else it's not going to work. We're not going to be allowed to, okay? So if we go back into my smart contract and we can hover over USDT, you can see that the first function that we have in the token smart contract is going to be the approve. And this works the same in production. We actually have to talk to the USDT smart contract and we have to send the approval to move those funds. Okay, so this can be done in production. What we need to do, we need to first of all copy our N2 USD reserves, smart contract address, and then we expand the approve section and we are going to specify that the spender is the N2 USD smart contract address. Okay, so we are pre-approving that spender from moving X amount. And now we have to approve that this spender moves X amount. In this case, it's going to be 200,000 USDT because that's what we minted, okay? That's what we have. So I already got the number, the value here. So I'm just gonna take advantage of it. I'm gonna paste it here and we are pre-approving this right now, okay? And now you can see my wallet that is sending, hey, by the way, you are going to allow your USDT balance and you have to specify what the amount is, right? So what I'm going to do here, by the way, it closed. Let me reject. For some reason, it timed out. So let me try it again. Okay, so what we need to do is we have to either set max or set default. It's just gonna grab whatever value we passed, okay? So we're gonna say next, and yeah, that should be it. Okay, so we'll wait for that. Once we're done, we should be able to deposit that collateral, okay? Okay, awesome, so we got the approval. And now what I have to do, I have to finally deposit the collateral. This is the moment where we are going to be passing that amount. Okay, deposit collateral. We're going to expand in our N2 USD reserves, deposit collateral. Okay, now vault ID, vault 0, that's the USDT vault. And then we are going to be passing the amount. In this case, it's going to be 200,000 USDT. We're going to transact. And this is the big moment. We're going to be depositing collateral into the reserve. Click market. I usually use market. We should get that confirmation. Boom, we got confirmed. So that means we have successfully transferred 200,000 USDT and it's currently being held in the reserves. Now let's take a look and see if this value changed. So we now have 200,000 USDT in this vault, okay? Now let's go ahead and add the second collateral, which is the wrapped ETH that we already have the address here. We're gonna add the second collateral and we are going to do here. Once we're done with this, we'll confirm that we have the second vault. And again, we cannot mint WETH because we don't know how much collateral or how much tokens do we have to mint based on the price, okay? And yeah, we should have that second vault and it's going to be vault number 1. And sure enough, there's the WETH smart contract and we have an amount of 0. Now to complete this and wrap it up, okay? I am going to show you in the block explorer, how does this look? We should see that the smart contract is holding the 200,000 USDT. Okay, perfect. I'm gonna paste the reserve smart contract and we can already see the amount of tokens. There we go. And who is holding that amount? It's my reserve smart contract. Beautiful, awesome. And you can see I deposit the collateral. So we call that function that we coded in the smart contract and we send from this address, my wallet address, into the smart contract. And currently we are holding 200,000 USDT. Let's test the withdrawal. And we're going to deposit again. Let's make sure that it works, okay? So what we got to do now, we are going to withdraw, okay? So what I'm gonna do, I'm going to type 0, and let me grab the amount. So we're gonna remove the entire collateral. I'm gonna pass here. We are going to transact this, and we are going to send confirm. Now we should have removed the entire collateral from the smart contract. Okay, it has been done. Now let's take a look at the vault. Remember, we had the 200,000. Boom, it's gone. That means that our math is working 100%. Let's now see the token smart contract and see who's holding. So now you can see the vault is no longer holding the collateral. It's been transferred into my personal. So we know that we are able to send and receive the collateral. We can withdraw, we can deposit, all that. And because we have to continue this journey, I am going to deposit once again the collateral. Hey, good thing that I did this. You know why? Because what just happened? Remember, we pre-approved the vault smart contract or the reserve smart contract from moving 200,000 USDT one time, which means what? I have to pre-approve once again, okay? Perfect. This is actually great that this happens. ERC20, insufficient allowance. Let me cancel, let me fix that. So what we're gonna do, we're gonna go back into the USDT and we're gonna approve it one more time because I have all the data, the details, everything there, okay? We got market, we're gonna say, okay. Once we're done, we'll deposit and it should be fine. It should be good, okay? Okay, cool. And we are going to try it one more time. Look at that, no errors, okay? We're gonna say market and we're gonna confirm. We should be golden. And boom, we have the collateral back in the vault. Awesome, we are done here. We have the 2 vaults, smart contracts. We have the 2 vaults generated. We have everything ready to go. We are waiting for the WETH math so then we can deposit the collateral, but we already have 200,000 USDT in our reserve smart contract. We are golden. Okay, in the next video, what we are going to be working with? We are going to be working with Chainlink Datafeeds. Why? Because I want to separate that topic, which is quite extensive, from the governance smart contract. Let's cover the Chainlink data feed and let's cover the governance smart contract on a separate video, okay? And the final video, it's going to be the graph, the chart that we're going to do, and we're going to see the price action live, okay? All right, so that's it for this video. I hope that you enjoyed a lot, and please practice, because practice makes perfection, all right? If you like this video, give it a thumbs up, subscribe if you haven't subscribed to it. Hey, and we'll see you on the next video. Bye.